If you first heard about artificial intelligence from movies in the 90s, you probably picture a menacing, red-eyed robot plotting to take over the world. That sense of unease is understandable. Those stories were convincing, and even highly respected scientists like Stephen Hawking have shared serious warnings about the long-term risks of advanced machines. But compare those fears to how we actually use this technology today. Right now, AI is suggesting what show you should stream next, or helping you draft a professional email. It is helping us navigate daily tasks, not attempting world domination. The reason it behaves this way is that modern artificial intelligence lacks consciousness. It doesn't have self-awareness, personal desires, or the ability to feel malice. It is more helpful to think of AI as a specialized mathematical program. While standard software follows a set of rigid, pre-written rules, AI is designed to look at data and learn from the patterns it finds. Recognizing AI as a mathematical tool instead of a conscious competitor allows us to stop worrying about what it wants. We can start focusing on how it works and how we can use it to our advantage. Let's look at how that learning process actually happens. Imagine we want to teach a computer a very simple task, identifying a bird in a photograph. We start by telling the program which physical features to look for. Things like wings, a beak, and feathers. The program then gives a specific amount of importance, or a weight, to each of those features. When you show the program a picture, it scans the image, adding up the scores for the features it finds. If the beak, wings, and feathers are all there, the math hits a high total and it declares a match. But look what happens when we show it a picture of a penguin. A penguin doesn't have standard aerodynamic wings, and its feathers don't look like the ones the program was trained on. Because those key features look different, the mathematical total drops. Following the weights we gave it, the system confidently, but incorrectly, decides this animal is not a bird. A traditional computer program would be stuck on this error forever. AI is different because it can actually evolve past this failure. This is the training phase. A person steps in, corrects the mistake, and tells the program that the penguin really is a bird. The program doesn't feel embarrassed. It simply adjusts its internal math based on this new information. It might lower the importance of wings and feathers while increasing the weight for beaks and two legs. After thousands of these corrections, the math becomes incredibly accurate. The system can eventually identify all kinds of birds it has never even seen before. Even after all that training, the program still doesn't understand what a bird is in the way a person does. It is strictly processing numbers and optimizing patterns. This is how AI functions. It's a mechanical system that refines mathematical patterns by using the feedback we provide. This ability to find patterns is already moving into more complex fields, handling work in everything from medicine to transportation. We are using these same mechanics to help doctors map patient genetics and to process the sensor data that lets cars drive themselves. Seeing software perform this well leads to a common worry. Will these systems eventually replace human workers entirely? The historical evidence suggests a different outcome. While technology often takes over repetitive tasks, it usually functions as a way to create new types of work. The World Economic Forum projects that as these tools are integrated into different industries, they could lead to roughly 170 million brand new roles globally. We're seeing a shift where humans act as the directors, managing these digital tools to get the best results. These new careers include roles like AI ethics officers. They will be responsible for checking the math to make sure these systems remain fair and safe for the public. We will also see more collaboration designers, whose main job is to build smooth, effective ways for people and software to work together on the same projects. Other roles will focus on the physical side of the technology, managing advanced robotics and automated transport networks. Movie myths often make us think the future is a battle between people and machines. The reality looks more like people using a very powerful calculator and working to build a smarter world together.